One of the most tedious parts of running a YouTube channel, especially an automated one, is the actual upload process. It's not just clicking upload file, it's setting the title, writing the description, assigning tags, uploading a custom thumbnail, choosing a category, and then, crucially, scheduling it for a specific date and time. Doing this manually for dozens or hundreds of videos becomes a bottleneck, and honestly, a soul-crushing chore. My goal was to completely eliminate this manual step for a new faceless channel I was spinning up. I needed a Python script that could take a video file, all its metadata, and a target publish time, and then handle the entire upload process autonomously. This meant diving deep into the YouTube Data API v3, specifically its video upload capabilities, which I quickly learned involved a multi-step dance with OAuth 2.0 for proper authentication and authorization. The first significant hurdle was authentication. The YouTube Data API uses OAuth 2.0, which means you can't just throw an API key at it for uploads. You need user consent. For a server-side or offline application like mine, this means using the installed application flow, which involves generating a client secret.json file from the Google Cloud Console. This file contains your client ID and secret. The Python Google Auth library handles much of the complexity, but you still need to manage token storage. The first time the script runs, it opens a browser window for you to log into your Google account and grant permissions. Once granted, it generates a token.json file which stores your refresh token. This token.json is critical, as it allows subsequent runs of the script to refresh the access token without requiring manual re-authentication, which is exactly what I needed for an unattended automation pipeline. With authentication sorted, the next step was to actually interact with the YouTube Data API. The Google API Python client library is the standard way to do this. You build a service object, typically like YouTube equals build YouTube v3, credentials equals credentials. The core operation for uploading is the videos.insert method. This method expects a body dictionary containing all the metadata for the video, snippet, status, and recording details if you're including them. The snippet is where the title, description, and tags go. The status is crucial for setting privacy public, private, unlisted, and, most importantly for my use case, the publish it field for scheduling. This date and time needs to be in RFC 3339 format, which Python's datatime module and .isa format method handle perfectly. Uploading the actual video file is done using the media body parameter of the videos.insert call. This takes a media file upload object from the Google authorlib.flow library. You provide the path to your video file, its MIME type e.g., video/ and whether it's resumable. Resumable uploads are a must for larger files, as they allow the upload to pick up where it left off if the connection drops. The API then handles the chunking and streaming. My pipeline typically generates MP4 files, so MIME type equals video/MP4 was the standard. After the insert call, the API returns a response containing the new video's ID, its status, and other details. I always capture this video ID and log it, as it's useful for debugging and for future operations like updating metadata or retrieving analytics. One of the most impactful elements for a video's click-through rate is the custom thumbnail. The YouTube Data API allows you to upload a thumbnail using the thumbnails.set method. This is a separate API call after the video has been uploaded. It takes the video ID of the newly uploaded video and a media file upload object for the image. The image needs to be a standard format like JPG, PNG, or GIF, and meet YouTube's resolution requirements, typically 1280 x 720 pixels. My video generation pipeline outputs a 1920 x 1080 thumbnail image, so I needed to ensure my Python script would first upload the video, get its ID, and then immediately follow up with the thumbnail upload. This two-step process means you can't upload the video and thumbnail simultaneously, but it works reliably. Error handling is paramount in any automation pipeline. API calls can fail for a multitude of reasons: network issues, invalid credentials, exceeding quotas, or malformed requests. I wrapped all API interactions in try-except blocks, specifically catching googlypicliat.errors.http error. This allows me to inspect the error code and message. For example, a 403 error might indicate insufficient permissions or an invalid API key, while a 400 could mean an invalid video title. I also implemented exponential backoff for retries on transient errors like 500 or 503, to avoid overwhelming the API and to gracefully handle temporary service disruptions. Logging all errors and retry attempts to a file was crucial for later debugging, especially when running the script on a remote server. The complete workflow looks something like this. First, the script retrieves a list of video projects from my SQLite job queue, each containing the video path, title, description, tags, thumbnail path, and desired publish it timestamp. For each project, it authenticates, constructs the video body including the publish it for scheduling, initiates the video upload, and upon success, extracts the video id. Immediately after, it uses that video id to upload the custom thumbnail. Finally, it marks the job as completed in the SQLite queue and moves the processed video and thumbnail files to an archive directory. This modular approach ensures that each step can be individually debugged and that the entire pipeline is resilient to failures at any stage, ready to pick up where it left off. This entire system cost me less than $1 a month to run, primarily because the API calls themselves are free up to generous quotas, and my Python script runs on a tiny serverless instance only when new videos are ready. The real value is in the time saved. What used to be a 15-minute manual upload process per video is now entirely automated, running silently in the background. It means I can focus on generating content and refining the video creation itself, rather than the mechanical process of publishing. This freedom to schedule content weeks or even months in advance is invaluable for maintaining a consistent publishing cadence on a faceless channel. If you've ever felt the drag of manual uploads, understanding the YouTube Data API is a powerful skill. I'll be sharing the core parts of this uploader script on GitHub next week for those who want to build their own.